Okay, this will be Unit 10 of AP Calculus BC. This is a BC only topic. Infinite series and sequences. So we are going to do a content review. Each of the topics will be covered, then example problems, and then we will eventually move on to some practice. So let's start by our first topic, defining convergent and divergent infinite series. Okay, defining convergent and divergent infinite series. So first, what is a sequence? A sequence itself is numbers in an infinite succession. Okay, so that's the best way I can probably describe it. And they follow a pattern. So numbers in an ongoing or infinite succession. Now, to write an example of this, we can have like 1, 2, 3, 4, or you can have 1/2, 1/3, 1/4, 1, -1, 1, -1. So we have all types, like alternating or constant, you know. So we can denote terms in a sequence with a subscript. So the first term of a sequence can be denoted by, let's say, a sub 1. Okay? And so the second term of a sequence, second, would obviously be a sub 2. So going on this model, the nth term, which is hypothetical value in sequence will be represented by the expression a sub n. Now this is important, okay, because we will be writing a sub n many times. And it's just a great way to not only express a series, but then set up your equations for evaluation as well. So you can generate the terms in a sequence by using a formula. So the sequence, we can have a sub n equals n minus 1 over n. And so if we start with n equals 1, then you have 0 as your first term, then we sub in 2, we get 1/2, then you get, I believe, 2/3, and then you get 3/4, on and on. Okay, and so this is found just by plugging in the number for n, and 1, 2, 3, so on, and n will always be an integer. So n, or I should actually say lowercase n, is always an integer. Okay? That is important to note. Move this here. Okay, perfect. Now, a sequence converges to a number. Converges to a number if, now I'm going to say these are our conditions. So our first condition is if as n gets bigger in value, okay, the terms get closer, or these are quotes right here, cap off at a value. And they'll seem to cap off. They'll seem to cap off as n gets bigger and bigger and approaches a value. Okay, and that number represents the limit of the sequence. Okay, the limit of the sequence. Wow, it is incredibly hard to draw lines with this. Okay. Okay. So let's move on. If we want the official formula, we can say a sequence has a limit L for any value greater than 0. There is an associated positive integer n such that a sub n minus L is less than e for all n is greater than equal to. Okay, so the calculus formula can be simplified. If the technical is too confusing, we can define it as the limit as n approaches infinity of a sub n equals L. Then we can say the series converges because it approaches a integer value. Okay, and that integer value is represented by L. L is a constant. Now, however, if the sequence let's actually go down a bit. If the sequence does not have a finite is very important in this situation, limit, it does what we call diverges. Okay, and this introduces our concept of convergence and divergence. So if we give an example of divergence over here, we'll say a of n, okay, we'll start off with convergence. A of n equals n minus 1 over n. And it converges because the limit as n approaches infinity of n minus 1 over 1 equals 1. Okay? 1 equals integer. Okay? So that means this converges. However, as n in the situation a of n equals 2 to the n, it diverges because the limit as 2, if we sub in, if we do limit of as n approaches infinity of 2 to the n, if we essentially substitute in, we can say the limit as n approaches infinity, essentially 2 to the infinity equals infinity, obviously. So as n gets continually bigger, the terms of the sequence get bigger correspondingly. So since infinity is not a definitive integer value, it diverges. Now, let's get into some further examples. We defined a sequence, okay? So we've just defined sequences. Let's define a series. Okay, a series is also very important. Series is an expression of the form a1 plus a2 plus a3. And this goes on, and we'll say plus a to the n plus ... after as well. And if the series stops at a final term, if stops at a final term, a sub n. Then the series equals finite. So if the series stops at a final term a sub n, the series is determined to be finite. So if the series continues if it continues instead of, if it continues indefinitely is the key term, indefinitely, then it's an infinite series. Now, obviously, sequence, series, and infinite series are all very important vocabulary you have to know, okay? My notes are a little messy, but I am just trying to get the concept across to you. I will be neater in my practice problems. Just make sure you are listening to what I am saying. Okay, so infinite series are the ones that primarily show up on the AP exam. This is what you have to worry about. A series is the sum of all terms in a sequence, okay? So if we've ever seen in physics, for example, the net symbol, or wow, that's horribly drawn, something like that. Wow, my physics teacher would be ashamed of me right now. Something like that. This is your net symbol, okay? So if we use infinity on the top and then n equals 1, and then of a of n, okay? So this is called, or what is known as, an infinite summation. And we just defined that, right? So we often use sigma notation. That's what makes sense. An infinite series is expressed in the form a1 plus a2 plus a3, continuing on to a to the n, right? And or in sigma notation, so I'll drag this, or actually change the color just so it's a little easier. What should we do? Blue. It's actually expressed by sigma infinity on the top, k equals 1, and then you can do a sub k. Okay? And so a1, in this situation, a1, a2, and a3 are terms of the series. A1, A2, A3 is terms of the series, right? And we go on until a to the n, or if it's infinite, it keeps going on and on. So in other words, an infinite series is a sequence of terms where the terms are added up. There's a pattern of the order of terms. There are an infinite number of terms. The following are all examples of infinite series, okay? So we have E, G, and then we have 2 plus 4 plus 6 plus ... right? Or we have e plus e squared plus e cubed plus e to the n, right? Or 8 minus 4 plus 2 plus, right? So we have all types of patterns. So let's look at how to find the sum of a series, right? Let's look at how to find a sum of a series. I'm going to highlight this as well. All the vocab, I mean, you should probably know by now if you're doing the content yourself. I highly suggest you go through some textbook problems on your own in order to practice. This is just to get some of the basic vocab and concepts down. Okay, but definitely if you have the Princeton Review or Barron's books, as well as like a textbook provided by your teacher, I would suggest going through that. Khan Academy course is good. If you need fundamentals, I would suggest doing Professor Dave as well on YouTube. He's very useful. organic chemistry tutor provides a basic overview of the concepts, all very useful resources. Okay, so let's look at how to find the sum of a series. Let S of n equals the sum, okay, I shouldn't say equals, stands for the sum of the first n terms of the series. Note I say first n terms, okay? So if we have S1 equals A1, I have S2 equals A1 plus A2, and so on and so forth. S3 equals A1 plus A2 plus A3, and it keeps going on, right? So if we wanted to represent S of n in sigma notation, then we would simply do, please forgive me if I'm writing these sigma symbols really small, okay? So make sure you get it in. N, k equals 1 at the bottom, and then you do A sub k. Okay, and the number S sub n is called the nth partial sum. Nth partial sum. And this means the sequence S1, S2, S3 is called the sequence of partial sums. S1, S2, S3, sequence of partial sums. And now don't quote me on this exactly, but an easy way to understand partial sums is sort of like the concept of factorials. You have 1 factorial is obviously 1, but 2 factorial is 2, and then you have 3 factorial, 3 times 2 times 1, and it makes sense, right? But in this case, it's addition. S1 equals A1, S2 equals A1 plus A2. It's the terms of the sequence being added together, right? So let's talk about the sum of a series in relation to convergence and divergence, right? So as n increases, the partial sum S sub n equals A1 plus A2 plus A3 plus dot 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 plus a to the n plus dot dot dot. Okay, and it includes more and more terms of the series. So if S sub n approaches a limit as n approaches infinity, right, then the limit is most likely the sum of all the terms in the series, and we call that convergence. So the convergence equals the limit equals, here I'll rewrite it like this, convergence limit equals the sum of all terms in a series. Right, so to be a little bit more technical, if we want to use some technical terms, if the sequence of partial sums converges to a limit S, this is a mathematical formula now, if the, I'm going to try and write this in a little italics manner, just so you know, of partial sums converges to a limit S, the series is then said to converge and S represents the sum of the series. Okay, so if S sub n, right, sorry, I'm regressing a little bit, but if we want to keep this in sigma notation, I'm just trying to follow what the textbook theorems are saying, so you know. Now, while I do suggest looking through, you have like Paul's online math notes and you have all these formula sheets, it's very helpful, but you have to know what each one of them means. You need to derive the meaning behind the formulas. Otherwise, there's no chance you're going to remember all of this, okay? It's the application of the formulas that will make you remember them. So again, do a lot of practice problems. So if the sequence of partial sums diverges, which means it doesn't have a limit, I will rewrite that. Diverges equals no integer limit. Then the series is said to diverge, right? So in this case, sequence of partial sums has no integer limit. So if I can draw a little arrow back here. Wow, that's horrible. It is a real struggle on Microsoft OneNote. I would just like to say that right now. Okay. No integer limit. If the sequence of partial sums has no integer limit, then it diverges. Okay. And that means it has no sum. Wow, how simple, right? It's nice. Okay, now let's do some practice. I love practice, right? Does the series 7/10 plus 7/10 squared plus 7/10 cubed plus dot dot dot, and then we'll do plus 7/10 to the n plus dot dot dot, or 10 to the k, let's say 10 to the k dot 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 converge. Now, how do we test convergence? There's a partial sum, right? So S sub n equals 7/10 plus 7/10 squared plus 7/10 cubed, so on and so forth. So if we have to multiply through by 1/10, right? So if I do 1/10 S sub n, then I get 7/10 squared plus 7/10 cubed plus 7. So I eliminate the first term essentially, right? You can view it as eliminating the first term. All right, and then what I do by doing this is I do 7/10 to the n plus 1. All right, and this is slight misrepresentation just because I should have a dot 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 in here, and then obviously a dot 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 here. Okay. You multiply through and then you subtract this form from S of n, right? So if I have Sn minus 1/10, I'll write this in brackets, 1/10 S sub n, what do we get? I'll write it all out, even though I really do not want to. 7/10 plus 7/10 squared plus 7/10 cubed plus 7/10 to the n plus minus 7/10 squared plus 7/10 cubed plus 7/10 to the fourth plus 7/10 to the n plus 1 plus dot dot dot. Okay, or actually we'll just say 7 to the 10 n plus 1. All right, now if we simplify this equation, you can write this as 10 out of 10 s to the n minus 1/10 s to the n, right? So that equals what? That equals 9/10 s to the n, which 9/10 s to the n equals 7/10 minus, which is what you get by evaluating all this shit, and then minus 7/10 to the n plus 1. And this gives us what? We get 7/10, and then 1 minus 7/10 to the n. Okay. Let me rewrite that a little better. And we have s of n equals 7/9, right? 7/9, 1 minus 7/10 to the n. And now we want to take the limit, right? We want to take the limit of this partial sum. So if this page loads, great. Limit as n approaches infinity, right? So we'll do lim n approaches infinity s of n equals 7/9. So therefore 7/10 plus 7/10 squared plus 7/10 cubed plus ... plus 7/10 to the k plus ... converges. Okay, because we get a integer value L, okay, which is 7/9. Okay. Now, let's do another example, and this is important. This is important, right? Let's do, does the series 1 minus 1 plus 1 minus 1 plus 1 converge? Right? And this question mark you can put after, that is my fault. Okay, so let's look at the partial sums. Let's do it again. S1 equals 1, S2 equals 0, right? Because it's, no, I'll do the math here just for your sake. 1 minus 1, right? So then we have S3 equals 1 minus 1 plus 1 equals 1. Now we have S4 equals 1 minus 1 plus 1 minus 1 equals 0. Okay, so the sequence of partial sums equals 1, 0, 1, 0, etc. Okay, and it clearly doesn't converge to a limit, right? We can see that in the sequence. 1, 0, 1, 0, it's alternating, right? So we're not going to get not converging. So diverges. Okay, I wrote 2 S's. So it diverges, right? And it can be tricky sometimes to tell whether a series converges or diverges, because in the next few subunits, we're going to learn some tests, okay? There's a lot of tests to remember. So again, this is the worst unit of Calculus BC. We are going to want to do a lot of practice, okay? And those tests you will have to remember. You do not get them on any formula sheets. So let's begin by moving on a little bit. All right, let's start with a new lesson, working with geometric series. Okay, working with geometric series. So the format for a geometric series will take the form A plus AR plus AR squared plus AR cubed plus AR to the N. Sorry, that looks like another N. AR to the N minus 1 plus dot 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 equals dot 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 infinity n equals 1 a r to the n minus 1. Okay, this is the format. This is the, wow, this is so difficult to use. This is the format for, I think somewhere around here, it's infinity plus 1 down, for a geometric series. It is very important that you recognize things like this, and you'll have to recognize different sequences later, even harder ones. You'll have to do e to the x and sine x and stuff like that. All right, so this one, just make sure you get down. Now, these series often show up on the AP exam. That's what I just said. You're usually asked to determine whether a series converges or diverges, and if it converges, to what limit. So let's sum that up real quick. Converges slash diverges, what limit? Okay. So in this situation, if we have a couple clauses, right? So if the absolute value of r is less than 1, okay, the series converges. That's very easy to understand, right? And so just like that, in another scenario, if the absolute value of r is greater than or equal to 1, the series diverges. And so in reality, you're going to have a lot of convergence tests, but it's more important, I would say now, that is a very, very loosely interpreted term. But it's very important to recognize patterns in how things diverge. Okay, so you can just recognize them on the multiple choice questions right away. So sequence, e.g., I'll do again for another example, 1/2 plus 1 over 2 squared plus 1 over 2 cubed, right? This converges because the series, and this, I'll give another example, 2, right? We'll start with 2. 2 plus 2, 2 cubed, right? This, it diverges. Now, if a geometric series, these are both geometric series, okay? Now, if a geometric series converges, you can always figure out its sum, all right? And it's very simple. If S of n equals a plus a to the r plus, oh, that's really messy, a plus a to the r plus a to the r squared plus a to the r cubed plus dot 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 a to the r n minus 1, right? If we, again, just like we did in that last problem, right? If we look up here, you see how we multiplied here by 1/10, right? Because that's the denominator. So we're going to do something a little similar here. We're going to do multiply r over. So we do rsn. Okay, and this leads into this. R times s sub n equals ar plus ar squared. See how it eliminates that first term, or offsets, you can say offsets by 1, a term in the sequence, plus ar to the n. And now it takes away this part right here. All right. So if we were to subtract the second expression from the first, again, right? Sn minus sr, please forgive me, minus r times s sub n, we get a minus ar to the n. And I'm just going to do this a better way. I'll factor out Sn 1 minus 4 equals, there's no point in factoring this side, ar to the n, right? So we do Sn equals a minus ar to the n over 1 minus r equals a minus r to the n, or oops. So there's my factoring there, 1 minus r, right? And then we move on by doing or deriving that if we want to find the sum of first n terms of geometric, we can use that formula right there. S sub n equals a to the 1 minus r over, that is an n, r over n, and then you have 1 minus r. Okay, so the first four terms, I'll say, for the example, do I want to do this example or another one? Okay, I can say for the first four terms in the sequence, just move on from this quickly after this. First four terms of sequence, I want to evaluate, so Sn, if n will be replaced by 4, you have 1/3, and then you have 1 minus 1/3 to the 4th, right? All over 1 minus 1/3. There you go, right? And so that will evaluate to what? Do some mental calculations. I believe that's 40 over 81, okay? Now, there is a slight difference for an infinite geometric series, okay? Infinite geometric series. Infinite geometric series. Right? For an infinite geometric series. If it converges limit of n approaches infinity, let's say of r to the n equals 0, sum s equals s, or we'll say a over 1 minus r. Okay, that is our expression. Now you can either derive, which a lot of students find easier, or memorize. And I honestly suggest memorize for the sake of speed. That is your personal choice. Okay. So as a quick example, I'll just do this one really quickly. Find limit to which series, and we'll do some 2 plus 2 over 5 plus 2 over 25 plus 2 over 125 converges. Right, so we do quickly. A equals 2, we should recognize, right? R equals 1/5, we should recognize. Okay, so if we do the limit, we have 2 over 1 minus 1/5, which is quickly 5 over 2. Right? So the AP exams treatment of a series doesn't get extremely complicated. It confines itself to finding the limit of an infinite geometric series. That's about it. Just remember the rule that if the absolute value of r is greater than or equal to 1, the geometric series diverges and has no limit. Okay? That is very important to remember. Now, we've covered quite some content regarding infinite series and sequences. In part 2 of this video, we will start going into the separate tests. There's roughly 9 you have to remember for the AP exam. And we'll start off strong with the nth term test for divergence. Thank you.